An Apollo astronaut once observed during his return to Earth that there was a great white lantern shining out over the bottom of the world. That light was Antarctica, the huge ice-covered continent that mankind is just beginning to understand. Until now, it was the only continent unthreatened by human progress. The last frontier is a continent of superlatives. It is the coldest place on Earth. Antarctica owns the world record for the lowest temperature ever recorded, minus 126 degrees Fahrenheit below zero. It's also the windiest place, with winds of 100 miles per hour not uncommon. Yet despite these unparalleled conditions, it supports amazingly abundant forms of life. "98% of Antarctica is covered with ice, some of it up to 2 miles thick, a burden heavy enough to push a third of the continental landmass well below sea level. In surface area, Antarctica is bigger than the United States. In winter, its ice cover extends outward over surrounding oceans, expanding to an area about the size of all of North America, plus Greenland and Iceland, both Eastern and Western Europe, and a good chunk of the Middle East. The huge icebergs that break off Antarctica's hanging cliffs and float out to sea usually drift 10 miles a day. Every summer, an estimated 1,000 square miles of Antarctic ice is lost to icebergs. We are now learning much about this remote continent because for the last 25 years, under a unique treaty, scientists from around the world have been coming to Antarctica to conduct research, to understand her forbidding environment, and to unlock her secrets. In the last few years, the world has come to think of Antarctica as the home of Earth's last uncharted natural resources. Sometimes, introducing this primeval world to the 20th century can bring strange consequences to its inhabitants. While Antarctica is fast becoming a curious blend of the newest and the oldest things on Earth, its history is the stuff of legend. The idea that a huge continent at the bottom of the world might exist was first proposed by ancient Greek astronomers who, looking at the stars, named the brightest of the constellations Arctos. So the Greeks called the North Pole Arctic, and they guessed that it would have a southern complement, which they called Antarctica. Now, geologists are proving that Antarctica has not always been isolated. It is believed that Antarctica was once part of a supercontinent called Gondwanaland, made up of Africa, South America, Australia, and India. According to the theory of plate tectonics, these continents drifted apart over several millions of years, with Antarctica moving south to the bottom of the globe. Enormous, ice-covered, and surrounded by the southern bodies of the Atlantic, Indian, and Pacific Oceans. It has been just 200 years since man ventured into the waters surrounding this frozen continent. In the late 1700s, Captain James Cook was the first explorer to cross the Antarctic Circle. Although he never sighted land, Captain Cook did encounter pack ice made of fresh water and thus deduced that there should be a continent further south. Cook also reported on the abundance of seals, an observation that sparked a wild flurry of activity around Antarctica. The 1800s brought seal hunters, who in less than 40 years virtually wiped out the seal population. Then came the next generation of hunters, the whalers. They came for the rich products of the whale, which went into soap and cosmetics, candles and margarine, and later into animal feed and fertilizers. Soon, the whales would go the way of the seals. Some species became almost extinct. Meanwhile, throughout the 19th century, the expeditions continued. From countries around the world came explorers in search of new lands and in search of the South Pole. In 1910, a British Royal Navy captain, Robert Falcon Scott, led an expedition to Antarctica. Official reason to conduct scientific research. But when he found out that a Norwegian explorer, Roald Amundsen, had already arrived to start a trek to the South Pole, Scott was shaken. Amundsen was Scott's old rival, and their simultaneous arrival started a race to the pole. Scott's preparations proved tragically misguided. He had brought tractors to lay down supply depots, but they broke down within miles of leaving base camp. He'd also brought 23 sled dogs, but none of his party knew how to drive them. In the end, Scott pinned most of his hopes on his ponies. Amundsen, on the other hand, was a seasoned explorer who had spent years training with the Eskimos in the Arctic. On October 19, 1911, he set off with a team of 4 companions and 52 sled dogs. They covered 1/6 of the 900 miles to the pole in the first 2 weeks. At about this time, Scott and his team started. The ponies, unsuited for harsh environment, soon became a disappointment. A month into their trek, the last one had to be shot. Some 2 weeks and 200 miles behind Amundsen, the effort began to tell on Scott and his men. On December 13th, 1911, Scott writes,
"A most damnably dismal day."
Ironically, Amundsen's original goal had been the North Pole. Having been beaten to it, he had turned south. On December 14th, he and his party achieved their goal. They became the first men to set foot on the South Pole. Scott, meanwhile, pressed on. He made a last-minute change, adding a 5th man for the final dash. It was a decision he would regret. It meant hauling extra food, and in a tent designed for 4, cooking or even drying socks took longer. On January 17, 1912, they arrived at the pole only to find Amundsen's tent and the Norwegian flag. Scott wrote in his diary,
"This told us the whole story. The Norwegians have frustrated us and are first at the pole. It's a terrible disappointment, and I'm very sorry for my loyal companions."
Days later, disappointment turned to tragedy. All were to die. The last 3, barely 11 miles from a supply depot. But the lure of Antarctica continued to inspire heroic deeds. With Amundsen's and Scott's achievement just 2 years before, another Briton, Ernest Shackleton, determined to try for the Grand Crossing, straight across the continent via the pole, a dangerous trip across and through Antarctic ice. So in 1914, he forced his ship, the Endurance, further into the ice of West Antarctica, wondering whether Antarctica would surrender the fame he sought so dearly. It did, but not quite as expected. The Endurance became trapped, and nothing anybody could do would get it out again. Shackleton ordered the ship unloaded and an emergency camp made. Finally, they decided to turn back, and there followed a truly incredible journey. First, 500 miles of drifting and sledding over the broken pack ice. And then, aboard lifeboats, they survived an 800-mile voyage in seas like this. Their failed attempt was valiant. Not one man was lost. Shackleton received a hero's welcome. By 1915, the South Pole had been reached by Amundsen and then Scott, while Shackleton's scheme to traverse the continent had failed. Transportation was the major problem for this generation of Antarctic explorers, but a solution was on the way. 15 years later, in 1929, American Richard Byrd would add the next dimension to Antarctic exploration, the airplane. Byrd wrote later in his autobiography, "At the same time I was learning to fly, the airplane was on the verge of becoming a tool which mankind could fit to his hand. My ambition was to test this tool to the utmost." The pole, he said, lies at the center of a limitless plain, and that is almost all there is to say about it. It is the effort of getting there that counts. Compared to what had gone before, Byrd's achievement seemed almost effortless, but just as heroic. One man who accompanied Byrd was geologist Lawrence Gould.
The first Byrd Antarctic expedition was the first American expedition ever to land in Antarctica. And it was also a critical one because it introduced into Antarctic exploration techniques and technology that had never been used before. As history shows, Commander Byrd, or now Admiral Byrd, after his first expedition, got so excited about Antarctica that he devoted the rest of his life to it. What he did on the succeeding expeditions was a natural succession of what we did on the first one, an increase in the scope of the scientific program, emphasis upon more things, a great deal of added mapping, a great deal of oceanography, seismology, and almost any science you want to think of. Indeed, what he did then was a kind of a preparation for the great exploration going on now.
Right up to the 50s, explorers from a dozen countries were staking out or renewing their claims to pieces of the continent. 5 nations claimed portions of eastern Antarctica. There wasn't much controversy here. Western Antarctica was a different matter. Here, claims overlapped. The United Kingdom, Chile, and Argentina became locked in sovereignty disputes about which parts of the pie belonged to whom. In 1957-58, the International Geophysical Year, IGY for short, took place. Despite the Antarctic sovereignty disputes and east-west tensions of the 1950s, the IGY was a brilliantly successful international cooperative effort, bringing together scientists from around the world to achieve a common goal, understanding Antarctica. Although Antarctica was not the only target of IGY research, it was one of the most important, since almost nothing was known about this huge continent until well into the 20th century. So during the IGY, scientists undertook extensive research efforts in Antarctica, collecting data from meteorological and seismic experiments, studies of the upper atmosphere and the deepest ice cover. Perhaps the most important immediate discovery was that it would take decades to thoroughly investigate the Antarctic continent, because its ecosystem was surprisingly more complex than first thought. So, in the wake of the International Geophysical Year, a dozen countries established year-round research bases on Antarctica, places where scientists could begin to conduct continuing studies of the continent. Throughout the Antarctic summers, these bases would brim with international scientists, often swelling the population to 1,000 or more.
Not whatever you like. Nice 20. Nice 20. Come from the score. Tissues are down. Oh, it's your turn now.
Compared to the living conditions of Scott and Amundsen, the Antarctic explorers of the modern era live in splendor, although not quite all of the comforts of home, like privacy, are available.
Morning.
However, when winter comes, the character of Antarctic research changes dramatically. Scientific manpower is reduced to a skeleton crew, almost completely isolated from the rest of the world. The IGY and the establishment of year-round research bases led to the historic signing of the Antarctic Treaty in 1961. One IGY scientist is Dr. James Zumberg.
Treaties usually are made by nations having a common interest in some part of the world for defensive or economic reasons. The Antarctic Treaty grew out of a scientific cooperation among nations that have vastly different ideological philosophies, different kinds of governments, are in different parts of the world, and the uniqueness of the treaty is that not only did it occur at the height of the Cold War between the two superpowers, but that it has been sustained and functioning well for 25 years.
Under this treaty, nations engaged in Cold War elsewhere on the planet agreed to share scientific data, and those nations who had staked out Antarctic land claims agreed to put aside their sovereignty disputes for 30 years so that science could rule supreme in Antarctica. The 12 treaty signatories, US and USSR included, would share the decision-making power. Membership would be determined not by ownership, but by adherence to the principles of the treaty.
Those nations who are willing to adhere to the principles of the treaty that are well enunciated, such as no nuclear testing, no nuclear waste disposal, that Antarctica will be free and open. You don't need a passport to go to Antarctica or a visa. That all the information gathered, scientific and otherwise, will be equally shared with all others. If you're willing to do that, you can sign the treaty documents and become a member of the treaty party.
While any UN member nation can sign the treaty, this does not automatically confer full decision-making status. From the International Institute for Environment and Development, Lee Kimball.
Only if you are doing major scientific research activities down there can you take part in decision-making under the treaty. And since the treaty was first negotiated, there have been 4 countries added to the original 12. Those are Poland, West Germany, and this year, Brazil and India. So you have to really demonstrate that you're doing a lot of research work down there by either a scientific station or a major research expedition.
Nearly all Antarctic research is international to the extent that data is freely shared. Most national activities are coordinated by SCAR, the Scientific Committee on Antarctic Research, an international body established in 1958. American geologist James Zumberg is SCAR's current president.
SCAR was designed right after the IGY to provide a scientific forum that would lead to the continuity of the work begun in the IGY and also coordinate scientific work in Antarctica. You see, Antarctic research is very, very expensive. For example, in the United States, for every dollar we spend on science, we spend $8 or $9 on logistics, that is ships and airplanes and fuel and bases and food and all of the backup infrastructure that it takes to send an expedition to Antarctica. So if you can collaborate and get many scientists on a single expedition, you'll be more efficient in the use of your funds.
One of SCAR's largest cooperative efforts is the International Antarctic Glaciological Project. Begun in 1971 and involving 6 nations, its objective was to study and determine the dynamics of the East Antarctic ice sheet. New Zealand geologist Peter Barrett.
We're drilling to find out the age of the East Antarctic ice sheet. We're actually drilling offshore to do this because the glaciers in Antarctica have been eroding and scraping away at the continent for millions of years now, and have left no record of this except offshore. The importance of the drilling to me really relates to the history of the Antarctic ice sheet, which is a feature that dominates world climate.
The current estimate is that Antarctica's ice sheet is 15 million years old, just 1/2% of the Earth's total history. In those 15 million years that this ice has accumulated, it has recorded the history of world climate. Trapped in layer upon layer of ice are undisturbed records of pollution, volcanic dust, and other atmospheric particles. By analyzing their contents, scientists are hoping to pinpoint not only the age of the continental ice sheet, but also whether it is getting larger or smaller, and why. At the University of Maine, George Denton is studying the relationship between the Antarctic ice sheets and world climate.
The fundamental scientific problem that we're attacking is the cause of ice ages. And the particular problem within this overall search is to discover why large ice sheets come and go in the past. One of the exciting things that we've discovered is that regional climatic changes in portions of the northern hemisphere have a widespread global effect. A slight climatic warming causes melting of the northern hemisphere glaciers. Water pours into the sea, and the worldwide sea level rises.
In Antarctica, this causes the ice shelves to lift off the underlying bedrock. This is just like loosening a cork in a bottle. It allows more ice to flow seaward, and this continues until a new equilibrium is achieved. This equilibrium, however, may be upset by a new phenomenon, the so-called greenhouse effect, in which increased levels of carbon dioxide in the atmosphere cause the Earth's temperature to rise, generating potentially dangerous climatic consequences. Industrialization has almost doubled the amount of carbon dioxide present in the atmosphere only a century ago, and global temperature has been rising. Some scientists contend that this warming trend will continue, and it will melt the polar ice caps, causing disastrous floods. Paradoxically, this warming could also cause the next ice age. Antarctica plays a central role in world weather. This great continent is our planet's most powerful weather machine because of its extreme ice age temperatures. And today's sophisticated equipment makes it easy for us to see the workings of this great weather factory. Daily satellite photographs show how the rotation of the Earth causes polar winds to twist into a ring of spiraling cyclones. The prevailing winds over the continent and the impact of cyclonic storms which form over the southern oceans and move clockwise around the continent are the great forces of this circulation system. They are what make Antarctica both the windiest and the coldest place on Earth. The world record low temperature of 126 below zero was recorded here at Russia's Vostok Station. The temperature never rises above the freezing mark in Antarctica, even in the summer. While the sun shines at the South Pole for about as many hours each year as it does at the equator, there is almost no warmth in the Antarctic sun because it stays so low on the horizon, even in midsummer, and the mirror surface of the ice reflects much of what little heat there is back into the sky. The seasons are simple: 5 months of winter darkness and 5 months of summer sun, with twilight in between. By definition, Antarctica is a desert. Because of its extreme cold, moisture is low, with hardly any snowfall, only 2 inches annually. The wind whips this snow around just like sand in the Sahara and gives the impression of a blizzard. The snow rarely melts, and over the course of millions of years, it has become compacted into the present ice cap. Not all of Antarctica is ice-covered. Areas like these are called the dry valleys, part of the 2% exposed Earth on the mainland. They were scooped out by the departure of enormous glaciers. Amazingly, only a few hundred miles from the pole, there is life here. The sun manages to melt water from the glaciers, water which is the key to Antarctica's rare plant life. Here also is the Onyx, Antarctica's only river, which flows only in the summer because it is fed by melt water. In turn, it feeds an inland lake, Lake Vanda. Changing levels of river and lake have become a simple measure of climatic change, and their water becomes the lifeblood of the 3 species of plants able to withstand Antarctica's harsh interior environment. Lichens are the most abundant vegetation. It is estimated that there are 400 species of lichens, 70 species of moss, and 96 species of algae scattered around the ice-free zones. One of Antarctica's rare land animals, a mite, is known to tolerate extremely low temperatures. In great contrast to the poverty of plant life, Antarctica supports a rich marine and bird life. An estimated 100 million or more birds return to Antarctica each summer to breed around the rocky coastline. Penguins are by far the most prevalent, accounting for 85% of the total bird population. Penguins spend about half their time at sea feeding. Their breeding colonies can be exceedingly large, for there are few sections of the coast sufficiently free of ice for nesting. Some rookeries have been estimated to contain as many as 250,000 birds. There are 17 species of penguins in the Antarctic. The unobstructed landscape of Antarctica makes it ideal for scientific observation.
Okay, where you go?
The Adelies, the most numerous of penguins and the most studied, start their breeding season in October, the beginning of Antarctic summer. The males come ashore after a winter feeding out at sea. The territorial instinct in the Adelies is very strong. They will fight hard to keep the same nest site as last year or try for a better one. New breeders try to muscle in. Not easy to do when space is so limited. With territorial claims settled, the males start to build new or repair the old nests. Pebble-sized rocks are the only available material, and tops of ridges are the prime sites. Both are necessary for drainage and to stop the eggs from rolling away. Some days later, the females come ashore. For the old couples, the task now is to re-establish last year's partnership. The Adelies' pair bond lasts a lifetime, about 20 years. After the noise and scuffle of mating, the successful pairs lay their eggs, 2 of them, and incubation starts. The parents take turns sitting. For protection, one parent always has to be about while the other goes to see to feed. All the unsuccessful birds go back to sea. They have to try again next year. There are many hazards which the parents have to overcome. A snowfall at the wrong moment brings spring floods, turning the rocky nests into little islands. For those feeding at sea, the need to enter and leave the water continually exposes them to the leopard seal. Although seals feed mainly at sea, a few hang around penguin colonies for an occasional meal. The most common hazard, however, is the skua, an Antarctic relative of the common gull. For the skua, egg raids on Adelie rookeries are an alternative to fishing. In December, the eggs hatch, and the parents announce the event with raucous fanfare. As the Antarctic summer is so short, the chicks must grow fast. By the time they are 3 or 4 weeks old, they get up to 1/3 of their weight at one feed. The meals are huge, although infrequent. To keep up with this demand, both parents spend most of their time feeding. That means occasionally abandoning their chicks, leaving them unprotected. Professor Ewan Young.
We've got a very close interaction between the Adelie penguin and the Antarctic skua. And that's a superb interaction because they are very common, both of them are very easily seen, so that you can look at different situations. Without really doing any counting or looking at the food required, everybody thought that skuas were entirely dependent on penguin rookeries for their food. But probably by far the greater proportion of them are feeding on their own at sea for most of the year. It doesn't take much observation really to see that they're not good at being predators. They can grab chicks all right and yank them out of a colony, but then they don't know what to do with it. The only way they seem to be able to kill them is to keep on banging the head down hard.
It is obvious that skua are much more skilled at sea feeding, where it is easier to swallow a whole fish than a floppy chick. For birds who have cohabited these regions with penguins for at least 6,000 years, it is a scientific mystery why they have not developed into better penguin predators. Meanwhile, the penguin chicks are learning the ropes of life in the Antarctic. In warm conditions, they lie around the territory like heaps of down and fluff. In bad weather and harsh conditions, the chicks huddle together very tightly to keep warm. Parents have to answer the ever-growing feeding demands, and feeding chases become common as the end of the rearing phase nears. In about mid-February, Instinct drives the young birds to face the sea for the first time. The breeding cycle is complete, and just 6 weeks from birth, the penguins leave their nests for good. The Antarctic is also home to the seal. Seals have adapted to the rigors of Southern Ocean life with great success. The Weddell seal is the most common and most at home in Antarctica. It keeps mainly to the shore ice. Although they are air-breathing animals, the Weddells spend remarkable periods underwater. The Weddells regularly have to gnaw breathing holes in the ice to keep it from freezing over. At the beginning of each Antarctic summer, the Weddells give birth. The newborn pups weigh about 70 pounds. They have very little fat, and at first it is the fur they are born with which protects them from the freezing winds. They have to put on fat incredibly quickly to survive. In 1 week, their birth weight doubles. By 6 weeks, when they'll be weaned, it will have gone up 3 times. After a week, the pups begin to enter the water. This is the time when the holes through the ice become as important as the food they lead to. The holes must never be allowed to freeze over. Gerald Koyman of the Scripps Institute of Oceanography has been looking at how Weddells dive.
The longest dive we've measured by a Weddell seal was 73 minutes. That's out of a sample of about 15,000 dives.
By carefully attaching depth recorders with radio telemetry to adult Weddells, Koyman and his colleagues have found out just how deep they go.
Here's the first one. Beautiful. Good. Okay, I got the slack on there one.
No, you can hear it, but it's very weak.
The radio signal is altered when the device is submerged, and they can tell just how long the dive is. The seal seems to be able to think ahead and adapt its metabolism and body functions to cope with the conditions it's about to face.
When Weddell seals dive, they anticipate the length of the dive they're going to make. And if they're making a long dive, the blood is restricted to the heart, the brain, and the lung. And in this way, on the longer dives, they conserve the oxygen stores in the blood for the essential organs.
In addition to their studies of seal respiration, the Koyman team is also investigating seal communication and echolocation.
Seals appear to make about 35 different calls underwater. When we analyze them, it appears that there are properties within those calls that could be useful for echolocation or sonar. We do know that some of these calls are used in important social contexts. Females use them for protecting their pups. Males use them for displays at territorial boundaries and for defending those territories.
While we now view the seal with fascination and with awe, 100 years ago, man hunted seals for their fur and blubber. But in recent years, most species of seal found within the Antarctic region have not been subjected to commercial exploitation, and their numbers are increasing. The more scientists study life in the Antarctic, the more questions there are to be answered. For example, scientists from the University of Auckland are investigating how fish survive the almost frozen waters beneath the Antarctic ice sheet. John McDonald.
If the fish we know at home were put into the freezing waters of the polar seas, they would rapidly cease to operate. On the other hand, polar fishes, Antarctic fishes, and Arctic fishes, living under these permanent ice cover, have adaptations which prevent them from freezing and enable them to continue living. These adaptations have been studied for the past 20 years and include such changes as low temperature enzymes and antifreezes in the blood.
The antifreeze ingredient is a natural glycol protein. It's a compound that stops the molecules of ice from developing into crystals. Here it is being injected into the bloodstream of a cod from warmer New Zealand waters to see if such adaptation is interchangeable. This glycol protein is simply nature's version of the antifreeze we put in our cars. There may be practical benefits to this kind of research. By understanding the workings of this natural antifreeze, we may find ways of improving methods of storing human blood for hospitals. So far, this research has been basic and not applied. Its aim is to understand, not exploit. Unfortunately, the same cannot be said about what humanity has been doing to the whale. The slaughter of whales in the southern oceans continued as the industry developed new, improved methods of hunting to escape quotas that were being imposed. By the 1970s, a ban on this kind of whaling was established, but not before some species were threatened with extinction. Back in the heyday of commercial whaling, the men of the British ship Discovery were conducting pioneer biological research of the Antarctic waters. Concerned by the declining number of whales, they were commissioned to make a census and to unravel the mystery of how these giants lived. While these scientists followed whalers to chart whale anatomy, they found in the bellies of the whales a tiny shrimp-like animal, krill. It is now believed to be the staple food of most Antarctic carnivores. Not surprisingly, krill has become the center of great commercial interest, and scientists worry that krill may soon meet the same fate as the whales once exploitation began. Dr. James Zumberg.
What we're trying to find out right now, and this is totally in concert with the Convention on the Conservation of Marine Living Resources, is how many tons of krill could be extracted from Antarctica on a continuing basis without destroying the ability of the krill to reproduce themselves and replenish themselves, so that we would in fact have a resource that is self-regenerating, or in the parlance of the resource people, a renewable resource.
The Antarctic Treaty Nations and the scientists succeeded in designing a conservation mechanism to regulate the eventual exploitation of krill and other Antarctic fish, and to protect all marine life.
They are concerned that the most abundant, or what appears to be the most abundant and the most likely exploitable Antarctic marine resource, krill, will not be overfished, or at least will not be harvested to the point that that stock is depleted.
However, the Convention on the Conservation of Marine Living Resources, which went into force in April 1982, does not acknowledge the interests of the wider international community beyond those members of the treaty or those technologically able to exploit these marine resources. Another resource of great interest in Antarctica is its potential mineral wealth. There is growing speculation that beneath the ice, Antarctica conceals large deposits of exploitable minerals. New Zealand geologist Peter Barrett.
There's been a lot of interest from the public in our drilling project, I think chiefly because people associate with drilling with oil and gas. And it's certainly true that oil companies are showing a considerable interest in the Ross Sea region, that the Antarctic treaty nations are very concerned about the possibilities for development and how it might be controlled. But this is not what we're drilling for. In fact, oil and gas is not the purpose of the project, but in spite of that, it's clear that if we do find gas, it's bound to bring the day closer when Antarctica is exploited for its mineral resources.
In 1974, the U.S. Geological Survey was not optimistic about the chances of discovering worthwhile mineral deposits on the Antarctic continent. Since then, however, geologists have verified the existence of several minerals, including copper, iron, zinc, and coal. Whether this evidence suggests large and extremely valuable deposits is not known. As for oil and gas, some reckon the continental shelf could contain vast quantities, perhaps several times that of Alaska's 8 billion barrels, but it will probably be extremely difficult and expensive to extract.
Many people have the idea that all you need is a shovel and a ship, and you go down and shovel the wealth out of Antarctica and load it on and take it back to some port. But the fact is that to do the kind of exploration and then exploitation would cost incredible sums of money, billions of dollars, before anything of value could be extracted. And there are very few nations or companies or consortia that can afford that kind of exploration at this time.
In times of crisis, it is not cost, but availability which matters. National security can often dictate that costly resources be developed.
In 1973, when the Arab oil embargo stunned the world by quadrupling the price of oil, there was a great flurry of interest in the mineral potential of Antarctica, especially with respect to oil and gas potential. And the treaty nations, aware of this, acutely aware of it, you might say, asked SCAR for the first time to evaluate the mineral potential of Antarctica and the environmental consequences if those minerals, including gas and oil, might be exploited.
I trust that your stay
Throughout the 70s, interest continued as more and more evidence of minerals in Antarctica was uncovered.
This meeting is an important one for SCAR, and a number of important issues are to be discussed. The future role and structure of SCAR, the SCAR response to the rapidly developing requirements for resource-related research, and in particular, the potential environmental impact of future mineral exploration and exploitation. We've lived through the era of pioneer scientific exploration in Antarctica. We're now approaching the era in which economic and consequently political interests may tend to dominate Antarctic research activities.
While diplomats huddled to speculate on the future of Antarctic minerals, scientists are coming to grips with the inevitability of losing their unique, unspoiled laboratory and their free association of Antarctica with pure science.
So I think it's a feature of Antarctic scientists that they have acquired over a relatively few years of work there, a sympathy for the Antarctic environment, which I would not really expect from people who haven't worked there. And I think this makes Antarctic scientists almost unusual among world scientists in other areas because there is virtually no other group of people that can speak for the Antarctic or represent it. It doesn't have any other population.
The knowledge gained through the scientific cooperation is what has brought worldwide attention to Antarctic resources. Global resource scarcity and uncertain political situations everywhere have reawakened this interest in the mineral wealth. The resource issue has revived old territorial disputes among treaty nations, and the desire to share this wealth is rising in the rest of the international community. To deal with all these issues, the treaty nations are furiously working to design a legal framework. Just as they came up with the Marine Living Resources Convention, the treaty nations would like to come up with an in-house mineral solution. These negotiations have been intense and secret, a design, some say, to keep the issues and the resources out of reach of countries not party to the treaty. Lee Kimball.
There are complaints about the treaty system that it's too secret, the meetings that take place under it, the negotiations, there's not enough information in the public domain about. And also that it's exclusive, that the countries who take part in decision-making are a small number, and that there ought to be a wider cooperation down there. There ought to be more countries taking part in decision-making. The criticisms are accurate. You know, it's a shame that the existing treaty has been as secretive as it has, and that has really raised a lot of false assumptions.
The treaty nations are attempting to address these criticisms. For the first time in September '83, they invited the 12 acceding nations to attend their biannual meeting as observers. They also accepted 2 new members, Brazil and India, into full decision-making status, bringing the total to 16. Some critics, however, feel that this response may be too little and too late. After all, 1991 is around the corner, and the treaty may no longer exist after that.
There's a common misperception about the Antarctic Treaty that it runs out in 1991. It doesn't run out. At that time, a country, a full consultative party, may request a review of the treaty, but it's not clear that a full consultative party will request a review of the treaty. And the big test for that is going to be the next 10 years, where between now and 1991, where if the treaty parties respond well to this increasing public interest, international community interest in Antarctica, become less secret, try to deal with the exclusivity charge, then the treaty will probably survive for a long time. The fear is that the response will be too slow or inadequate, in which case there may be a country that requests a review. And I don't know what the result would be. I hope the result would be as effective in preserving the environment and world peace as the present treaty we have.
I'm forced to the conclusion that exploitation is likely to take place in the foreseeable future. And given that, there are 2 areas that I see that we should be concerned about. One is the biological environment, not so much the immediate impact of spills, but the gradual increase in levels of oil in the Southern Ocean as a consequence of development over many years. The other area is in the effect on the Antarctic ice sheet and on the climate of Antarctica. The Antarctic is, in fact, quite a fragile place. The problem I see arising is that in the near future we're likely to have a 100-fold increase in human activity in the Antarctic, and this activity may be of a very different character from the scientific activity that's taken place. I also think they will want results quickly because the criterion will be the economics of the operation. And I see this as a significant threat to the Antarctic environment.
While the 20th century has seen many of Antarctica's icy secrets revealed, the dawn of the 21st century will undoubtedly be the most active period in the history of the Antarctic continent. Mankind will soon have to decide whether this final frontier will remain a peaceful haven for international scientists or meet the same fate as the rest of the world: habitation, followed by development and exploitation.